Imagine you want to sneak a big picture onto your wall, but you don't want to disturb anyone while they're busy. That's what requestIdleCallback does with web tasks. We use it to load an image only when everyone in the room is idle, no disruption. So, we queue up the image loading task, and once the room goes quiet, the image quietly hangs up on your virtual wall. You get your picture without slowing anything down, the perfect background task. Imagine you're trying to solve a massive jigsaw puzzle, but you don't want to miss the party happening around you. That's where requestIdleCallback steps in. It lets you tackle the puzzle piece by piece in your spare moments. Our function, perform heavy task, uses this clever trick. It works away at the heavy computations only when there's free time, so the rest of the tasks, like updating our progress bar, never gets held up. That way, your computer's UI remains as smooth as the party vibe. Imagine you're sipping your coffee while your computer is juggling tasks in the background, smoothly updating a progress bar on screen. By using requestIdleCallback, the browser picks the perfect moments of inactivity to crunch through a list of tasks without causing any lag. It's like your computer knows exactly when to multitask without spilling that coffee. Once a task is done, it updates the progress bar using requestAnimationFrame to keep things silky smooth. Pretty nifty, right? Just hit start and watch the magic happen, one idle moment at a time. Imagine setting up a low-priority task that can run whenever your computer takes a breather. That's what requestIdleCallback does. It's like saying, hey, when you have free time, do this. But there's a catch. Things can get busy, so your task might wait. And wait. That's where a timeout comes in, kind of a nudge to say, do this task within 2000 milliseconds, please. It keeps things running smoothly, ensuring no task is left behind in the hustle of computer life. Imagine we're managing tasks smartly to keep the browser running smoothly. So, we've got this function process idle tasks that chews through tasks when the browser is just kicking back. Now, say it crunches some numbers but still has more to munch on. What it does next is slick. It asks the browser, hey, can I have a spot in the next idle window? By calling itself again with requestIdleCallback. This way, we're playing nice, not hogging the browser's time. It's like we're politely taking turns with the browser to get stuff done. Imagine you've got a bunch of non-urgent tasks, like slowly decoding alien messages from space. Cool, but not a rush. You want your computer to handle other important stuff and get to these when it can chill. That's where requestIdleCallback swings in. You tell it to run your functions when it has free time, even setting a timeout, so if it's been too long, it'll get to it, promise. It's like giving your tasks a take-a-number system, keeping everything smooth and responsive. Isn't that a neat trick? Picture this, we've got a backroom operation going on in our browser where some pretty low-key tasks need doing. The kind that don't get the spotlight. These tasks are chill, hanging out in the back, waiting for their chance to shine when the main stage cools off. But there's a sneaky trap called task starvation, right? Sometimes that main stage is like an epic rock concert that never ends, and our easygoing tasks might never get their moment. To keep things fair, we schedule them with a timeout, sort of like giving them a VIP pass to jump the line every now and then, so they always get a chance to strut their stuff. Imagine we're managing a conveyor belt in a factory, but instead of products, we're piling up tasks for our computer to handle later. Now, if we get too excited and overload this belt with, say, 10,000 tasks, we're headed for trouble. It's like cramming a shopping cart until the wheels buckle. Performance dips and memory gets crunched. Our code here wisely puts a cap on tasks and sends a flare with a warning notice if things look risky. That's how we keep our virtual factory running smooth and avoid a digital traffic jam. Imagine you're juggling tasks, and some are just too complex, causing you to drop them when rushed. In code, when our performance budget runs thin, didTimeout is our cue to simplify the task at hand. This clever flag lets us know if our function's running because of a timeout. If it's true, we streamline the task to prevent snags. We keep chipping away at our tasks, but if we can't wrap them up in time, we queue them up again. It's like a smooth dance. constantly adjusting our steps to the rhythm of the browser's idle time. Hey, you know when you schedule a bunch of low-priority tasks but then need to stop them from running? That's where Cancel Idle Callback comes into play. It's like telling an eager helper to take a break. First, you get a handle when you schedule a task, then if you need to halt it, just call Cancel Scheduled Task with that handle. Remember to clear the handle afterward so you don't cancel it twice by mistake. Then you're all set to start fresh without leaving loose ends.